Also, keep in mind that pressure and moles are directly proportional. As pressure increases, the moles of gas increases. Thus, as there are more moles of gas in a state of increased pressure, the frequency of collisions increases, thus making it more likely that the reaction will be able to overcome the activation energy barrier. For the effect of concentration, we will be looking at an equilibrium mixture of chromate and dichromate ions. In this reaction, the variation in the concentration of the hydrogen ion will decide what direction the equilibrium will lie towards. We will assume equal concentrations of chromate and dichromate are present initially at equilibrium. However, if we add a base, such as sodium hydroxide, the hydrogen ion concentration decreases as it reacts with the hydroxide ions. Thus, equilibrium shifts to the left, with the solution being predominantly yellow in color due to the higher concentration of chromate ions. A saturated solution is a solution in which the maximum amount of solute per volume of solvent has been dissolved. No additional solute will dissolve in a saturated solution. The Ksp value of a saturated solution depicts the extent of dissociation of a certain compound in water. For example, let's take a look at barium hydroxide, which is a slightly soluble salt, and calcium carbonate, which is even less soluble. This is because of their Ksp values. The equilibrium of calcium carbonate lies further to the left, hence it is less soluble. The equilibrium expressions for both include only the ions. Now we will predict a precipitate. The first step is to calculate the moles of the participating ions. Then find their concentrations using the total volume of the solution. We then calculate the reaction Qtio Q and compare its value with the Ksp value. Since Q is less than Ksp, a precipitate will not. For our second question, we follow the same steps. However, in this case, the final value for Q is greater than the Ksp. Hence the solution is referred to be supersaturated and a precipitate will form. In the previous question, the solution was unsaturated, hence a precipitate did not form. One more thing to keep in mind is when Q is equal to Ksp. When this is the case, the solution is saturated and at equilibrium. Thus, a precipitate will still form when Q is equal to Ksp. Thank you for watching this video. We hope you have learnt something new or had your memory about equilibrium refreshed. Be sure to like and subscribe. Psych.